Alright, polarization. We don't talk about it much, although we should talk about it. Now, we all learned about, and this diagram's not going to be great, but we all learned when we looked at light that we described it as an electromagnetic wave, the amplitude in this plane being the electric field, and hopefully you got told that there was another one at 90 degrees, that one there. That was the magnetic field. Magnetic field. So we thought about in it a light wave, obviously this wavelength here, for green light would be 500 nanometers. So it gives you an idea of what's happening, very small. And we can relate that back to our wave equation, A times sine of omega t minus kx, or plus kx, depends which way it's going. But the whole point being the k relates the wavelength, omega the frequency, and this electric field has a direction. Now the point being that if we are linear, we have two types of polarization. Linear polarization means that you've got your waves all lined up. All their electric fields are vertical. So if we had a whole bunch of waves going into the page, if you like, this way, and their electric fields were going up and down, up and down, up and down, vertical, then that would be called vertical polarization. But you could have them all going into the page, if you like, horizontally polarized. Obviously, this little arrow here go backwards and forwards as the wave travels that way, because it's a transverse wave. Just like this one, we go backwards and forwards, backwards and forwards, backwards and forwards. And that's the electric field that we're talking about. Now obviously, if that's the electric field and that's the way the wave is going, then you'll have a magnetic field going backwards and forwards horizontally if the electric field's going vertically. And with the electric field going horizontally, you'd have a vertical magnetic field going backwards and forwards all in time as the wave goes into the page. So this would be horizontal polarization and vertical. And you can get filters like that. And if you take any wave with any sort of polarization, because a wave could have a polarization this way, right? Goes backwards and forwards this way, electric field. But that's got a component this way and a component this way. So any wave can be broken down into vertical and horizontal components for its electric field. The thing being, if you cross two polarizing filters, a polarizing filter only lets one component through. So if you cross two filters, you'll block out the vertical and then the horizontal, and it will go dark. Now that's linear polarization, which is quite simple. But then we've got something called circular polarization. That's where, believe it or not, the actual electric field direction vector is rotating. So you might have it in that direction, and it's rotating as the wave travels. It's actually rotating, right? Now obviously it can rotate clockwise or anti-clockwise as it goes into the page. So you have a right hand or a left hand circular polarization, right? So that's important. And often what happens when something reflects, like off a screen, it goes from a right circular to a left circular. And that can be useful if you've got a filter. Now, that's how we sort of get rid of reflection in photography, using a circular polarized filter. Alright, now, and there are other things here. Reflections often involve a polarization of some sort, and I think they say that birds use polarization because of the polarization of sunlight at certain times of the day. Some people can pick it out a little bit, I think. What else can we say about this whole circular polarization? The waves that come down from the satellites for our Sky TV are polarized. So inside the LNB, so you've got this dish, right, on your roof, and the waves are reflected to this LNB block that's all connected to your TV, right? In that LNB block, that circular, if we look at it on the inside, take the top, we'll see two pins. One of those pins is going to receive the vertical polarization, and one is going to receive the horizontal polarization. So you can actually transmit two signals on the same frequency and just have one vertical polarization and one horizontal. And then inside the TV, when you set your transponder frequency, well, in the past, before it did it automatically, you had to set the vertical or the whole horizontal polarization, and it would take the signal from whichever one you'd set. Okay, I think that's all I really wanted to say on it, because we don't really cover it in physics.